solder. It's been around for a very, very long time. And I'm going to share with you our experience and some of the things that we learned in constructing a, not micro-LED, mini LED backplane assembly, backlight for a tablet. And there are some things that were learned that I think will be useful. Another thing that I've realized is that we are so, this technology is what's in use today. And there may be some things that are practical that you can apply to your application today. It's not some of the blue sky stuff that I've heard in the presentations earlier today. So, been a very impressive group. So, I come from the surface mount world. We make circuit boards. And the smallest components that you would see in a traditional printed circuit board assembly are typically called 01005s. And they're about 400 by 200 micron rectangles. The application that we were successful in a production scale was using a mini LED that's about 150 by 100 micron. It was 4 times smaller than anything anybody had worked with in a traditional surface mount assembly line. And obviously, I thought 50 by 50 was incomprehensible, and now you guys want 5 by 5. Good luck. But here we are. And this is just to demonstrate the difference in scale for a traditional surface mount application. 0201s are a very common component that are used during printed circuit board assembly. 01005s are common for your mobile applications and your smaller devices, handheld devices. And then that to scale is the mini LED that we use during the assembly process. I don't think my human hair is visible, but they're small, trust me. So we use solder paste. Solder paste has been around, I've been in this business since 1994, and that's about when surface mount started to gain a lot of traction as a commoditized process. It's flux medium. I'll refer to medium a lot of times. It's the term we use internally. It's goo, like wheel bearing grease. And alloy powder. And alloy powder is 90% of the material by weight, so it's mostly alloy powder. It's about 50-50 ratio by volume. And controlling the size of the spheres to blend the material has a lot to do with your success in whether or not you can print these very, very fine features in a traditional surface mount printing process. And a traditional surface mount printing process is a lot like silk screening a t-shirt. You have holes in the stencil where you want the material to transfer through it. It goes through the hole and it deposits itself on whatever's underneath. It's very precise and sophisticated in this application, but fundamentally that's what it is. These are the, so the type goes in reverse of the size of the sphere. The bigger the number, the smaller the sphere. So type 4 is what's commonly used in surface mount assembly today. Type 5 is being used, it will be more common. We're preparing for that product to become mainstream over the next 2 to 3 years, I'd speculate. And type 6 is finer still. And you can see the ratio of the size of the spheres relative to one another in the different mesh sizes. So I have a range. I get to be this big and this small, and I have to fit the powder in between that range in order to assign it a type. And as you can see, type 4 is significantly larger than type 6 and type 7. That's really the tipping point for the technology in terms of reflowing a solder paste successfully. As the balls get smaller, the oxide layer relative to the ball is the same. So each one of these spheres has an oxide layer that's roughly 3 to 5 nanometers. So the mass of metal can shrink, but the oxide layer will stay the same. And we need a little oxide layer on there because the oxide layer prevents the solder particles from sticking together. If you had very pure solder particles, they'd clump. So the challenge is that now I have this oxide layer that I need there for the powder to work properly. I then have to strip that oxide layer away during the reflow process using the flux medium so that the solder will coalesce into a single contiguous mass. One of the advantages to solder versus some of the other materials that were discussed today is that it's metal. It's one solid piece of metal. It conducts heat very consistently. It conducts electricity very consistently. And in this case, the industry uses a tin, silver, copper, predominantly lead-free material. That's what I'm talking about. When I'm talking about this stuff, there are a lot of other alternative alloys that